Thank you, Shirish. I just had to unmute myself. So here I am. Let me go to the PowerPoint slides. Good morning to all of you. I think we got a friendly fireside chat here to do today. We've got a critical mass of Granger plus Sierra. Hopefully, we'll get some of your clients as well on the call. As Sharice mentioned, on the CRO for SIERA.AI. As a company, we are dedicated to innovative technology solutions for safety. And my talk today is going to be focusing not on pitching SIERA.AI, but how to actually use AI technologies such as analytics and deep learning to foster safety in material handling. And so it's going to be about how we use all of that telematics data that we collect during all of the compliance and operational safety procedures, for regulatory safety, for operational safety, and how can we apply AI algorithms to all of that data to foster safety in material handling. In the past, I have done a talk which is about using AI across the whole spectrum of safety, from regulatory safety to more of operational safety, and then to proactive safety, etc. But this time around, I'm going to limit myself. How can we use this data to get at diagnostics, that is answering the question why? Predictive analytics, such as to understand the answer to the question, what could happen, and then answers to the question, how can we prevent something happen, meaning prescriptive analytics. Okay, so let's get on to that. But before we do that, a short introduction to who we are, what we are. It's not a big plug. We are a company focused on forklift safety using AI across our technology stack to provide for forklift safety solutions. Not that we are focused only on forklifts, but it's across a whole range of assets, powered industrial vehicles. We are a venture-backed technology company, started in Austin in 2017, but now we branched off into having an office in California as well as in North Carolina. And we started with AGRs, AGMs, and those acronyms don't mean much if you're talking about automation in the fullest way, automated guided robots, automated guided machines. But very soon we saw an unfulfilled demand for risk mitigation with digital compliance for OSHA regulatory safety, right? Like such as digital inspections, checklists, and reporting, and then graduated to operational safety, and then to proactive stuff. Across the whole spectrum of the safety procedures, we have data that is being collected, and that's what I'm going to be talking about. How do we apply AI to all of this? And as we are capturing on the slide, we have increased productivity and efficiency in enterprises with more than 1 million incidents, accidents being averted. That itself is a major cost. And by no means is the list of customers or logos up there on the screen exhaustive, but these are all like really good ones. And several of them have come through our channel partner, Granger, well represented today on our session. But what we find across all of our customers so far is that they share one big thread in a common vision, which is how do we address safety, given the fact that accidents cost a lot of money, and non-fatal ones to fatal ones, you're talking about all the way upwards from $188,000 to maybe $500,000, etc. So how do we actually address that? And herein lies the rub, and that is our SIERA.AI solution, which covers the whole range of safety, all the way from providing a pillar for digitizing and collecting all of the telematics to digitize the workflow relating to regulatory safety, from digital inspection checklists all the way to providing for compliance reporting, etc., and keeping a historical view of that. And this is where applying AI algorithms to get that insights really come in. And then moving on to operational safety as a larger pillar, where any kind of incident, the data relating to that, to the impacts, and then moving on to proactive safety is collected. Okay, and guess what? Despite all of this, despite even our solutions being there, accidents happen. And that question needs to be addressed, okay? Because operators are human. So how can we let the drivers focus on doing what they have to do, that is drive and improve productivity, while we can use AI on the telematics data to maintain safety, right? How can we actually address those questions, as I talked about, the why, the diagnostics, and then how to predict events, and then how to prescribe some remedial measures to make sure that these things don't happen again. So before that, let's understand what goes on in this big loaded keyword called telematics, right? So what does it entail? So it's all about the data on assets, right? Assets such as the powered industrial vehicles, your forklifts, your pallet jacks, etc., kind of thing, and data on operators. And they could be just your forklift operators. They could be actually also administrators, etc. And then the incidents that happen, the impacts, etc. And then the operational pathways. So you're talking about data that's spread around certifications, uncertified accesses, authentications, authorization privileges, unauthenticated, unauthorized accesses, the inspections that we go through, the failures of it, mechanical or electronic, and then all of the fleet data, the make and model of the equipment, what are they operating, battery voltages, the loads that they carry, and the work that they actually is being done, what's that job fit, and the utilization of all of that, the hours of use, the uptime, the downtime, and the failures, etc., and the fail time, and also the maintenance time that is spent in servicing, and the tracking of all of this within workspaces, be it manufacturing or your distribution facilities, which means that the pathways that they take, the hotspots, the danger zones, etc. Also data relating to how we can monitor for all the vehicle speed, operator behavior even. I mean, there are cameras also monitoring some, not just in our case, but in cases that used by other enterprises, other solutions, where even safety belt use is being monitored. Okay, all of this data, the telematics data, can go into a single repository, which means that you can apply AI, which is analytics on it, to get some meaningful information to address the questions of why and what and how. And let's examine how that comes about. But before that, again, what is AI? Of course, if you've all been seeing the news, especially from the stock market these days, the NVIDIA just jumping all the way, defying laws of gravity, if you will, right? So, but very simply, it's about endowing machines with human-like thinking capabilities, right? That's about, in the simple nutshell, defining AI. In our case, it is not just about this expansive definition of AI, about generative AI. It is much more about predictive AI, where we can take data that we collect and apply deep learning analytical algorithms to get some meaningful data out of this, especially diagnostics, predictives, and prescriptives. And that's the kind of focus I'm going to actually carry through in this presentation. And feel free to ask me questions as we go along, what we are and how can we, what we are talking about, as well as, so let's examine your focus. Is it going to be on the fleet? Is it going to be on assets? Is it going to be on operators? Is it going to be on the operational paths? Is it going to be on the facilities, the space, and the security and the safety? So let's sort of examine the constituencies, examine what is being collected, and let's review what can we do with all of this data, what can be expected out of it. Well, most importantly, what's the outcome that you want? out of it. At the end of this day, it's not technology for technology's sake. You got to get something out of it. Otherwise, you're not going to be spending money, right? And that's really the nature of things, especially we're not talking enterprise IT. We're talking to safety directors here. We've got some meaningful KPIs that they need to actually address. So let's sort of follow the money here. Who are the constituencies here? Who can be help? And what data to collect? And here we see three big constituencies. You're talking about facilities such as the manufacturing or warehousing, distribution centers, the data that can be collected on the paths, the tracking within the loading zones, the dispatch areas, the pedestrian areas, the high danger zones, accident prone areas. I mean, we talked to a Granger customer who talked about this whole area that's cordoned off where there's a loading zone, and then there's one which is just the dispatch zone, etc., which entails some newer outcomes that they want out of this, right? And the same thing goes for assets. You're talking about a whole range of things in material handling, like powered industrial vehicle covering forklifts, and it could be pallet jack, it could be order pickers, and scissor lifts, reach lifts, etc., kind of thing. The data on the fleets of them. Some enterprises have large numbers of them, and the data on make, the power, the energy utilization, their maintenance, downtime, all of that data. What do we make out of it? And the operators can range all the way from forklift operators to administrators, etc. So let's examine what can we get. And the big outcome that you want, especially if you're a large enterprise, and we have heard from some of them who've got not tens, not hundreds, we're talking about thousands, we're talking about 10,000, even 100,000, we have heard those kind of numbers, right? So how can we optimize those fleets of large material handling equipment, okay? And which means that with all of the metrics, the data that is collected, what can we get out of this, right? So, and it's about the fleet optimization is about rationalizing the size of the fleet, the distribution, their composition, not in just one site, also across sites, okay? It also means how to get the appropriate fleet, right? Heavy versus the light duty, matching jobs all the way from heavy jobs to the light jobs, and matching operators to it, in operators to assets, okay? So it's also about utilization of the fleet, right? Their efficacy and efficiency. You don't want to have significant downtime where, a whole bunch of this thing is just sitting and you're wasting all of that big capital expenditure, right? So the data, the diagnostics, the telematics data that is collected, the make and model, their age, hours of operation, etc., can be used by applying algorithms to get some diagnostics, which is about the average use time, the average downtime, the average loads, etc. Now, couple that with data on future loads. I mean, a company could know, hey, look, how is our business expanding? And that means you can actually get the ideas of what the future loads and the future activity. We are going to add one more shift or three more shifts, etc. Now we can apply the AI algorithms, right, analytics, to sort of like predict using the prediction of the growth of the fleet, to using the prediction about the growth of business to match the growth of the fleet to the growth of the business. And the AI analytics can also prescribe the right mixture and composition of the fleet across within a site for the growth of the business and across multiple sites, okay? And what we end up getting is that we get a better picture of how to actually run our business, right? And what this entails also is about predicting replacement in the future, as well as prescription for and a roadmap for replacement of assets and for purchase of. Okay. Now, let's talk about all the energy utilization. You may have propane, you may have electric. At the end of the day, it's all about buying energy. So if you've got the diagnostics as to and the telematics data, for which gives you the information as to how much of energy is currently being used, and you have ideas about your growth of business, then the analytics can point and predict as to how this will grow, and prescriptive analytics can give you a picture for what would be the optimal use of energy and how could we actually purchase out of that. Okay, so in some ways you're talking about forward purchasing for current use, etc. Similar things that I mean, you take airlines today like United. They do this, and they are biggest players in the energy market, buying fuel for all of their fleets much before time. So in other words, so they sort of like even out all of those peaks and valleys in energy prices over a period of 5 years, 10 years, because they optimize the fleet and they optimize the energy usage of that. Okay, and the same can be said about tracking the route of a lot of the fleets within. If you have all of the telematics data of the pathways that you take within workspaces, you get the spaghetti diagram of where your forklifts are traveling within, and you can understand the redundant tasks that they're taking and optimize on that. Again, I can use an example of United Airlines using actually flight data and also the altitude where they need to fly to encounter the lowest minimum headwinds, etc., to optimize the pathway from point A to point B, etc. kind of thing. The same can be applied here. And you're talking about large enterprises, you're talking about large costs, and I'm talking about outcomes that you can get by using technology, getting there, right? And same goes for maintenance, where you can predict maintenance scheduling. So where you can get at service times that are pre-scheduled, so that you know exactly how to actually have a fresh fleet to work with the task at hand, and can in a prescriptive way can order for stocks of replacement parts and fuel, etc. kind of thing. Moving on to asset optimization, the same can be applied to what you need to do with assets. Okay, the big question in asset optimization is to extend the life and the productivity, right? The big question is, how long can my asset last, right? And that means to get at the health profile of asset. The telematics data that you collect can give you an idea about the wear and tear, the servicing, the repairs, maintenance, etc. And all this can give you a sort of a health profile of assets, their operating life, their residual life, and use it across the capacity of fleets to make sure that your whole capability and capacity, is that going to be reduced over time, or is that increase, etc. Right? So we can apply AI algorithms on all of this, right, on all of the assets and the impacts that they have and the data that we collect on impacts, etc., to get at a risk profile of assets, not at one site, but across all sites. Now, if you combine this with all of the data that's collected on operator handling of it, meaning whether the operators are handling it in a smooth way or a rough way based on their behavioral information, hard cornering or rapid acceleration, rapid stops, hard stops, etc., you can get a safety score. Right? So risk profile, safety scores, and with these two, you can literally predict a replacement strategy, and a prescriptive analytic would be whether it's a purchase or lease, etc. kind of thing, right? And the same thing goes for maintenance scheduling as well. You can predict what needs to be maintained and prescribe for all the spare parts, etc. And also, you can create a picture of what numbers of your assets or what portions of your assets are more impact tolerant, so we can order more of those brand names compared to others. I mean, on a commonsensical way, we apply this to all of our cars that we have purchased over time and driven in our lifetimes. We kind of know, oh, gee, my Toyotas are far more resilient to abuse, and I can sort of like postpone their maintenance compared to my German models that, have to be administered some tender loving care and humongous bills, right? that kind of thing, right? So moving on to understanding how can we utilize on all of the operators and operator costs, and they play an important role in the workspace environment. And in today's very tight labor market, that probably is the biggest expense that you may have all be encountering. How are my people doing? That's a very important question. And that requires data on operators, right? Tracking all of the driver data, their certifications, their authorizations, the classes of vehicles that they can operate, the loads they have carried, and help scheduling the right operator, right assets, etc. And that's really important. And I think AI analytics can help solve that. Now, and that can also provide for and tracking all of their impact data, right? Capturing the picture on that and applying AI algorithms on them can give you analytics on the risk profile of operators, okay, based on even in a site, okay. We have clients where they know exactly who are the errant operators and where are they maximized and which site is most dangerous, etc. And that's great to get that risk profile. Now, combining all of the, let's say, their behavior, hard cornering, rapid acceleration. We can also get at the safety profiles of operators, in which means that based on that, you can have prescriptive steps in measuring, evaluating, and improving driver safety, right? You can probably, and you can have scorecards on operators, and you can also have refresher courses for us that can be scheduled for them, training, and also it can result in understanding what newer safety technologies, such as like lane departure and forward collision warnings, that you can actually give safety managers and the operators immediate insight into drivers' actions. Okay, look, at the worst, you can also predict who is and which site you have drivers that need to be replaced. So at the end of this day, at the end of this, you need to understand that given the fact that we are operating with humans here, with AI analytics for rationalizing on operators, it needs to be taken with the dose of caution here, because it is quality of versus technology, right? So quality of life, culture within an organization, etc. So and to give you an instance, even taking an operator picture within many of our enterprise clients, we have found is impinging on culture and behavior within, especially leading to union demands that it should not be actually captured, etc. So companies have to surpass all of those kind of hurdles in order to use technology to change user behavior, is my point here. But nonetheless, it should be done, it needs to be done, etc. kind of thing. So let's understand how can we actually use the diagnostics and predictive prescriptive analytics in workspace automation as well. So facility managers look for efficiency, productivity within workspaces, right? So and you know, we have collected some data from National Safety Council kind of statistics that are being published, that any kind of workspace that has more than 10 forklifts is twice the number of accidents happening. And if you have ever experienced in life within manufacturing facilities, these things zip around at pretty good speeds. And I can tell you, even at 2 to 5 miles an hour hit is enough to actually send you to heaven, right? It's a dangerous situation if, especially, you have multiples of the forklifts zipping around and you have pedestrians crossing the place as well. So, which means that trying to get at some safe procedures and safe maps within for operations is a good thing. So with all the telematics data, that is collected about impacts. You have the geolocations, the geo coordinates where these things happen. So you have the ability to actually identify and map danger zones, the hot zones, if you will, right? In which what that means is we can use then predictive analytics to geofence these high impact areas as no-go areas, etc. You can also have prescriptive analytics to help in reorienting pathways, reorienting space, and redesign of the workflow, etc. So in many ways, the predictive analytics applied on telematics data that is collected relating to space is to identify danger zones where accidents take place, identify risky pathways where pedestrians crossing. And then prescriptive analytics is to help slow down the vehicles based on that information, reorient space, pathways, optimizing the pathways like a Google map, if you will, and geofencing all of these danger zones and creating the Google safety map for operators. And it's all about calculating an efficient path, and we are using AI, much like what you have today in Google Maps, going from point A to point B. You can pick and choose, give me a pathway with no tollways, no highways present, where, lots and lots of fuel stops are available, etc. So the attributes that can be used to actually pick what you need, etc. Moving on to actually understanding what you can get in terms of security and safety, they kind of fall in two buckets, okay? Using AI analytics and telematics data, you can get at both mechanisms for preventative safety and for reactive safety. Meaning, with the data that is collected, you can prevent non-certified users, non-authorized users getting on machines, okay? Not authenticated authorized users operating assets, okay? You can also prevent a not so well maintained asset being operated, so prevent bad use assets being ever used. You can prevent taking unsafe pathways, okay? And you can prevent drivers driving without seatbelts. That could be easily implemented, right? And then there's this other whole branch like reactive safety, right? So when a high impact happens, your operator cannot run away because we can shut down the machine. We can make sure that they're identified and the incident is investigated. And we hear from a lot of clients today that for years they've not done any of that, but now you can't. Inspection fails, you cannot also run away. You have visual alerts when danger lurks around the corner, and both the pedestrian and the operator can react to it, right? We have risk profiles, safety scores of assets and operators. So this can be they're used as a factor to prevent danger from happening, etc. We can go on and on in terms of different things that you can do. At the end of the day, it's all about utilizing data and applying algorithms to increase the efficiency on the workflow. Okay, so that pretty much brings me to everything that you can get, but there might be more scenarios. I'd love to hear from you all as to what other outcomes that you may expect. But at the end of the day, it's all about collecting the data from the instrumentation. At the end of the day, all that we do as SIERA.AI is to fit electronic instrumentation, just a hardware and a software combination, collect all of that data into a cloud server, massage it, do something interesting with some AI algorithms, and answer those questions relating to diagnostics, to predictives, and to prescriptives. And the pathway that you're taking all the way is to help you with safety, hopefully add bit by bit, incrementally. This is incremental evolution. It ain't a revolution. To help you with assisted technologies to carry you through the next steps of providing you more safety, but also along the vectors of better control and automation until you reach a certain point where there is a higher degree of autonomous driving within, okay? I know several others have taken this big path of jumping all the way to giving you the highest level of automation, but it ain't providing you the level of safety that you require. So that sort of brings me to the concluding here. We can open up for questions if you have any, and let me just jump into this window here where I can see you all. Yeah.
Great. Thank you very much, Ram. I do appreciate all of the detailed information. Matt, Tom, do you have any type of questions you'd like to ask?
I am good.
Ram, great presentation.